So trigonometry. Before that, we'll talk of Pythagoras theorem. In a right angle triangle, we talk about Pythagoras theorem. This is opposite. This is hypotenuse, while this is adjacent. So that will be opposite if this place is theta. If there's an angle theta here. Now by Pythagoras theorem, it says that the square of the hypotenuse, that is b square here, is equal to sum of squares of the two other sides, that is a square plus c square. I believe you are aware of that. So we take note of that, b square. Also we know from Secant that sin theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, while tan theta is opposite over adjacent. We define the reciprocals of these trigonometry functions, sine, cos, and tan. For sine, the reciprocal is cosec, that is 1 over sine. For cos, the reciprocal of cos is sec, while cot theta is 1 over tan theta. Also, we should know that tan theta is sine over cos, therefore cot theta will be cos over sine. From this Secant here, opposite over hypotenuse, we can have that sine theta is, this is our opposite c, this is our hypotenuse b, c over b. We got our c, our cos theta, and our tan theta. Now the first one, let's divide this equation 1 by b square. If I divide this equation by b square, I'm going to have a square over b square, c square over b square is equal to b square over b square. That is what we have here. So we now see that a over b here is cos, but there is square there to become cos square theta. This one too will be sine c over b. Then c square over b square will be sine square theta. B square over b square, that one is 1. So we have that cos square theta plus sine square theta is equal to 1. Also, if you make cos square theta the zero formula, you have 1 minus sine square theta. If you make sine square theta the zero formula, you have 1 minus cos square theta. Also, if I decide to divide both sides by a square, you know, I've divided both sides by b square. If I divide both sides by a square, what am I going to have? We are going to have, now we are going to have all this. If I divide both sides by a square, from this place, a square over a square is 1. C over a is tan. Definitely c square over a square will be tan square theta. Now the next one is b over a. B over a, there is no b over a, but we have a over b. A over b is cos. Definitely b over a will be the reciprocal, which is sec. So in that case, this place will become sec square theta. From this place, I can have sec. If I make tan square theta is a formula, I will have sec square theta minus 1 is equal to tan square theta. Also, I can have sec square theta minus tan square theta is equal to 1. From this place, if you make 1 the zero formula, plus tan square will go to the other side. So similarly, we can get another result. So also, we can have this 1 plus cot square theta is equal to cosec square theta. And playing with this, making all these zero formula, we have these results. So these results are what we call them fundamental trigonometry identities. That's what we call trigonometry identities. So the results, once again, you have to memorize all of them. They are very, very important. Pause and memorize them. Now let us now consider some other concepts. Consider complementary angles. If angles are complementary, we say that two angles are complementary if their sum is 90 degrees. Now, if you consider this right angle triangle, we have theta here. Definitely, the second angle will be 90 minus theta, since their sum must be 90. Under complementary angle, we normally use it to interchange trigonometry functions. For instance, if I want to change sine to cos, I can decide to change it. If I want to change cos to sine, I can decide to change it. Look at this example now. From this diagram, I can find out that sine theta will be equal to what cos 90 minus theta will give me. Also, cos theta is sine 90 minus theta. That is, if I see sine theta, what that means is that if you have sine 30, if I want to turn this sine to cos, it will still be the same thing as cos 60, because 60 and 30 will give me 90. Also, if I have tan, let's say tan 40 degree, it will still be the same thing as cot 50 degree, because 50 and 40 will give me 9. So if two angles are complementary, then we can use them to interchange two trigonometric functions. Another one is special angle. Special angles are 30 degree, 45 degree, and 60 degree, or any angles in their multiple. The multiple will be like, for example, multiple of 30 is 180, 120, like that. They are special angles. For special angles, we have all this, which you must take note and memorize. Sin theta is half. Sin 30 is half. Cos 30 is root 3 over 2. Tan 30 is 1 over root 3, or root 3 over 3. Like that, like that, like that. Okay, that is that about that. Another one is quadrants of angles. Now, quadrants of angles. So the quadrant, this is first quadrant. We call this place second quadrant, third quadrant, fourth quadrant. Another thing you should know is that any angle that will fall in this first quadrant must be in between 0 and 90 degree. In the second quadrant, 91 to 180 degree. In the third quadrant, 181 to 270 degree. And in the fourth quadrant. So this is what we call quadrants of angles. Another quadrant of angles, the first quadrant, the sign of this theta will always be positive. So in that case, I will say that this place is plus, this place is plus, this place is plus. That is, tan of any angle that fall in this place, all of them will be plus. So let me put A here to represent all of them. In this second quadrant, sign of any angle that fall here will be positive. The rest will be negative. So only sign will be positive here. Also here, any angle that fall in this place, that is 181 to 270, sign will be negative, cos will be negative, only tan will be positive. So I'll put T here. Also in this last quadrant, this will be negative, cos of this angle will be positive, and this will be negative. So this place is, so in this place now I have only cos that is quadrant. So if you look at it, CAST, that is cast. That is, C means cos, A means all, S means sine, T means tan. Another thing, what do we normally use quadrant of angle for? This quadrant of angles, we normally use it to reduce a higher angle. When you have something that is not of this nature, or that is not in first quadrant, we can use any of these to reduce the angle to the first quadrant without calculator. Now, how do we do that? Let's consider an example how we do it. Let's say example, we want to evaluate sine 120 degree. If you have sine 120 degree, the first thing, in order to simplify using the quadrant, I'll first check where 120 degree falls. In this place, this is where it falls. It falls between 91 to 180. So in that case, it falls in the second quadrant. Also, we are giving sign. You check whether sign is positive or negative there. Sign is positive, so you just say that your answer is plus sign. You open a bracket. You now consider what is here. What is here? What is here is 180 minus theta. Theta is the given angle. 180 minus the given angle. And that will be sine. 180 minus 120 is 60. But sine 60 from this place is root 3 over 2. Now let's consider another example. Let's consider another one, cos 240. To solve this, we first check where 240 falls. And where 240 falls, what is the nature of cos theta there? So if you look at it, 240 falls in the third quadrant here. And nature of cos there is negative. So our answer will just be minus cos. Now this 240 will change. What will it change to? It will change to what is there. Theta minus 180, that is the given angle minus 180. This is 240 minus 180. Our answer will now be 240 minus 180 will give me 60. That is minus cos, and we have known that cos 60 is half. So in that case, our answer here is minus half. So let's assume that we are now giving this. Let's say we are giving tan 480. You observe that 480 is more than 360 because even the whole of this quadrant ends in 360. Whenever you are giving such an angle that is more than 360, the first thing is, without even checking the quadrant, remove the angle, remove 360 from the angle. That is, we say that 480 minus 360. Without even checking it, I will quickly say that I will have 480 minus 360, and that will be equal to tan 120. So that means 120, tan 120 is what I'm really looking for. So I will now check where 120 falls and what is the nature of tan there. If I check it, 120 falls here in second quadrant, and nature of tan there is negative, so that my answer is minus tan you use 180 minus theta, that is tan 180 minus 120, that is minus tan 60. So from what I gave you here, tan 60 gives me square root of 3. So in that case, I cannot come here and say that my answer is square root of 3. That means tan 480 is same thing as minus square root of 3. So that is that about quadrants of angles. Now I'll quickly move to inverse quadrant. So inverse quadrant. Before that, we first talk about inverse quadrant. Inverse trig, sorry. Now if sin theta is equal to y, then theta is equal to arc sin y. This is a sign of sin raised to power minus 1. It's not the same thing as 1 over sine. No? We call it arc sin y. Likewise cos, likewise tan. So let us now draw the quadrant of this inverse trigonometry function. This is table of the inverse quadrant. It's just like the other one. The only difference here is that this place is 180 plus theta. The other one was theta minus 180. But here now is 180 plus. That's the only difference between this one and the other one. And what are we using this inverse quadrant for? For instance now, here we said if sine 30 degree is equal to half, definitely 30 will be equal to arc sine half. What that means is that sine 30 gives me half. Definitely 30 will be inverse of half. Then it can now be a question. Let's say we now have theta. Let's assume that we have theta. To know what we are using this quadrant for, let's say we have sine theta is equal to half. We are looking for theta. Let's say we want to find theta. Here, what this question is saying is that sine of something has given me half. What is that thing? The first thing is I can quickly check my calculator if I don't know, but I'm conversant with this. I will first write it as arc sine half. But we know that arc sine half will give me 30 degrees because sine 30 gives me half, just like what I wrote here. We are familiar with that. But what this quadrant is saying is that it is not only 30 degrees that the sine will give me half. We still have other angles that if you find a sine, you are still going to get half. That is the essence of inverse quadrant. Now, how do we get this one? Let's assume that we have found theta to be 30 degrees. Now, if you want to check the other angle, I'll just check the question. The question is half, positive half. I'll go and sine. So that means I'll check anywhere sine is positive in the other quadrant apart from the first quadrant. I'll check anywhere sine is positive. So this is where sine is positive. So from what we have there, we have 180 minus theta. So you can now say that your answer is equal to 180 minus the theta you got, which is 30. Our answer is 150. So that means theta is 150. This simply means that sine 150 is same thing as same thing as 1 over 2. Sine 30 is 1 over 2. Sine 150 is 1 over 2. So let's consider more examples on this. Now we consider these examples. Find the values of theta such that 0 is less than theta is less than 360. What this thing is saying is that we want to find the value of theta such that theta is positive and also theta is less than or equal to 360 degree. Theta starts from 0. And the first one gives me, the first one is cos theta is equal to minus 0.5. Now, the first thing, I will say that theta is equal to arc cos. I'll write it like this, arc cos minus 0.5. Which I'll write, let me bring the minus out. Minus 0.5 arc cos, when you check that in calculator, so if you check minus 0.5, it will give you 60 degree. If you brought the minus out, arc cos 0.5 gives me 60 degree. But they have told us that theta is greater than 0 and theta is less than 3. So we have not gotten our answer. We need to know what is our answer. In that case, let me keep my theta here. I will neglect the negative. I'll keep 60. Now, I will now come to the inverse quadrant. Before going there, come back to your question. Negative is given here and cos is given. So you need to know, you need to look for where cos is negative. Where cos is negative, we need to look for it in the inverse quadrant. And in the inverse quadrant, we have two places where cos is negative. Cos is negative here in the second quadrant, and what we have there is 180 minus theta. In the third quadrant too, cos is negative, and what we have there is 180 plus theta. So my answer is 180 minus 60. You know 60 is what we got, and 180 plus 60. I cannot conclude there that therefore theta is 180 minus 60, or theta is 180 plus 60. Therefore, our theta is 120, or theta is 240 degree. For the second one, I want to consider tan theta is equal to root 3 over 3. As usual, let me first know what is my theta. Theta will be arc tan root 3 over 3. When we check this from our calculator, it will give us 30 degree. So we already have 30 degree. From that, I can find the other angle. Since we have 30 degrees positive, then it is still within this range. I can find the other angle. How do I find it? I'll come back to my question as usual. I will look. We are giving positive number here, and you are giving tan. You only need to look for where tan is positive, and the only place where tan is positive in the three remaining quadrants is this place. Tan is positive here, and what is given there is 180 plus theta. In that case, my second theta is let me call it theta 2, is 180 plus the theta that we got, 30 degree. This is 210 degree. So that means the final answer to this will be 30 degree and 210 degree. And the last one there, sin theta is minus root 3 over 2. So for the second one now, sin theta is this. Theta will be arc sine minus root 3 over 2. Let me bring the minus out. Now let's finding this one from the calculator, it will give you 60 degree. So 60 is, we have minus 60, so it's not within this range. So we need to use the quadrant to find the remaining angles. Now, you come back to your question as usual. Negative is given and sine. We need to check where sine is negative. Any quadrant where sine is negative. We know that sine is negative here, and sine is also negative here. And what we have here is theta 180 plus theta and 360 minus theta. So our theta is representing 60 degree that we got here. Therefore, I can say that our theta 1 is 180 minus 60. Theta 2 is 360 minus 60. Finally, our answer will be equal to 120, and our answer will be equal to 300 degrees. So that is that about quadrants of angles. Let's consider another example on this. Find the value of theta such that this, if 3 minus cos theta is equal to this. So we are given this equation. When you are given this type of trigonometry equations, the first thing is find a way of making this thing to be the same thing. That is, turn this sine. Is very easy for me to turn this sine square to cos, because I can use it using trigonometry identities. The first thing is, let me recall that sine square theta is equal to 1 minus cos square theta. Just like what I gave here initially, this is it. Sine square theta is 1 minus cos square theta. Cos square theta is 1 minus sine square theta. So in that case, I will substitute it here so that I will have 3 minus cos theta is equal to. So we have this is our sine square theta now. If you expand, you have 2 times 2 cos square theta. Now, if you rearrange, minus 2 cos square theta, when it comes here, it becomes plus 2. This is our minus cos theta here. Also, when this 2 comes here, you are going to have 3 minus 2, that is 1, which is 0. So we form the, it leads to this equation. Now, we need to solve this equation. It's a quadratic equation, whereby our A is 2, B is minus 1, C is 1. Use quadratic formula, which you normally call almighty formula, this. If you use this formula, so we should have, there is 3 here. That will lead to external solution. There is 3 here. There is 3 in this place in the equation. 3 is here. 3 is here. 3 is here. So our B is minus 3. So our answer will now become 3 into 9 square minus 4 into 2 over 2a, 2 times 2. So this will give me 3 plus or minus 1 over 4. From that place, we can now say that our cos theta is equal to 3 plus 4 over 4, that is 1. Or cos theta is 3 minus 1 over 4, that is 1 over 2. So it has led to what we did before. We now need to solve this. To solve this alone, we have theta is equal to arc cos 1. And theta is equal to arc cos 1 will give me 0 from our calculator. But to get the other angle, I will look, we are giving 1 here, which is positive. Cos is also positive. So in that case, I can check where cos is positive, and that is 4th quadrant. And what is there is theta minus 360. So our answer is 360 minus theta. That will be 360 minus 0, that is 360. Also, from this place, theta will be arc cos half. And arc cos half will give me 60 degrees. So we need to get the second one. Cos is positive. And where cos is positive, what we have there is 360 minus theta, minus 60. Our answer is 300. Finally, our theta will be equal to 0 will be there, 60 will be there, 300 will be there, and 360 will be there. So that will be the solution to this equation. Let's consider another example on this. We want to find theta if sec square theta minus 3 tan theta minus 1, also for which 0 is less than this, for which the theta is bounded within this region. Now, for what I said before, you make sure that these trig functions are the same thing. So you have to make use of the trig identity, this one, which says sec square theta is equal to 1 plus tan square theta. So in that case, I'm going to recall, to solve this, I'm going to recall this. So this is a given question. Instead of this sec square theta, I will just put 1 plus tan square theta is equal to 3 tan theta minus 1. So let's rearrange. If you rearrange tan square theta, if this one comes here, we have minus 3 tan theta. When this minus comes here, we have plus 1. That will be 2. 1 plus 1 will give me 2. So this one leads to quadratic equation as well. And if you solve the quadratic equation, you are going to have 3 plus or minus root of 3 square minus 4ac over 2a. So finally, our answer there will be 3 plus or minus 1 over 2. From that place, I can say that tan theta is equal to 3 plus 1 divided by 2 is 2. Or tan theta is equal to 3 minus 1 divided by 2 is 1. Now let's first talk about this. Here I will find theta is equal to arc tan 2. To find theta here. But arc tan 2 from our calculator will give me 64.44 degrees. We need to know the second angle of this. And we will now go to the inverse quadrant where 2 is positive. So we check where tan is positive on the inverse quadrant. Inverse quadrant is the only place where tan is positive. And what we have there is 180 plus theta. So in that case, our other theta will be 180 plus 64.44. And that will be equal to 244.44 degrees. Also, I'll find theta here. Theta is arc tan 1. From our calculator, it will give me 45 degrees. I'll check where tan is positive, just like this. It's the same thing. What we have there should be 180 plus 45 degrees. And that is 245 degrees. The value of theta will now be equal to, if I pick it one by one, I can have 45, 64.44, 244.44, 245 degrees. These are the values of theta that will satisfy this equation in this range. Now let's move to trigonometry identity. 3 questions on trigonometry identities which we have here. These are the formulas we'll be using for these questions. Now let's consider some examples. If sin theta is equal to 4 over 5, find cos theta. To find cos theta, I will use the formula. I will recall that cos square theta is equal to 1 minus sin square theta. And that will be 1 minus, our sin is 4 over 5. Sin square theta will now be 4 square over 5 square. That is 1 minus 16 over 25. And 1 minus 16 over 25 will give me 9 over 25. To making cos theta the same formula, we have square root of 9 over 25. And that is 3 over 5. So that means if sin theta is 4 over 5, then cos theta is 3 over 5. Example 2. Prove the following. The first one. Sec square theta plus sin cosec square theta. We want to prove that it's same thing as sec square theta plus cosec square theta. So let's prove it. I just need to recall that sec is same thing as 1 over cos. So in that case, this one will be, okay, let me start from the left hand side. Sec square theta cosec square theta will now be equal to 1 over cos square theta, because sec is 1 over, is reciprocal of cos. Also cosec is reciprocal of sin. This is 1 over sin square theta. And if you expand, it should give me 1 over, if you multiply together, 1 over cos square theta sin square theta. So from our trigonometry identities, we know that 1 is same thing as sin theta plus cos square theta. I've shown you the other time. Instead of this one, I'll put cos square theta plus sin square theta over cos square theta sin square theta. From this place, I can separate this denominator under the expressions of the numerator. So this one will become cos square theta over cos square theta sin square theta plus the other one sin square theta over cos square theta sin square theta. And that will be cos cancel cos. If cos square cancel cos square, what you have left is 1 over sin square. Also, this cancel this, we have 1 over cos square. Finally, what we have here will become 1 over sin is cosec square theta plus 1 over cos is sec square theta. And that is what we are asked to prove. Sec square theta plus cosec square theta. This is it. Cosec square theta plus cos square theta. Let's consider another example. To show that this one is equal to 1. If they ask you to show, just need to start from this, then you need to bring this out. If you have brought it out, then you have shown it. To continue with this, I need to recall what 1 plus tan square theta means and what 1 plus cot square theta means, which I have given you. 1 plus cot square theta is cosec square theta. 1 plus tan square theta is sec square theta. So in that case, this one will become sec square theta. This one will become 1 over, this one will be 1 over cosec square theta. But 1 over cos square theta is cos, 1 over sec square theta is cos square theta. Also 1 over cosec square theta is sin square theta. We recall also that this one, cos square theta plus sin square theta is what? Is 1. So in that case, we have shown it that this is equal to 1. Let's consider another proof to show that we have to show that this is equal to this. And how do we show that? We need to recall that cot is cos theta over sin theta. That is for cot. Also, cosec is 1 over sin theta, then all square. Our aim is to show this and bring this out. From this list, let's find the LCM. LCM is sin theta. If you find the LCM and simplify the fraction, we have this. From this place, I can write it as 1 plus cos theta all squared over sin square theta. I put, by law of indices, I put the square on both sides. We now need to recall that this sin square theta here is same thing as 1 minus cos square theta. In that case, our left hand side will become 1 plus cos theta. You know, all square means another 1 plus cos theta divided by, instead of this sin square theta, I will write it as 1 minus cos square theta. I can now use difference of two squares, which is a minus b is a square minus b square is a minus b, and a plus b here can be written as 1 square. So that our a is 1, our b is cos theta. We are going to have 1 plus, the numerator is this. Why the denominator will be, you will use this, it will be 1 minus cos theta into 1 plus cos theta. From this way, you see that this will cancel this. They are the same thing. What we are going to have left is 1 plus cos theta over 1 minus cos theta. Proved. That is what we are asked to prove. That's what we are asked to prove here. So let's consider another example. Prove that, okay, to solve this, we need to recall that sec is 1 over cos. Also, sin square theta is 1 minus cos square theta. Therefore, the left hand side here, this one will become 1 over cos theta minus 1 over, this one will be 1 minus cos square theta. For the numerator, let me find the LCM. For the numerator, LCM is cos theta. This is 1 minus cos theta divided by this denominator. Denominator will be, if I use difference of two squares, just like what I used here, it will be 1 minus cos theta into 1 plus cos theta. In that place, we are going to have 1 minus cos theta over cos theta times 1. This division turns to times. The 2 will go down. 1 minus cos theta, 1 plus cos theta. From that place, 1 minus cos theta is cancelled. We know that 1 over cos means sec. Finally, 1 over cos there, this 1 over cos has become sec. And this one is at the denominator over this. So that is what they asked us to show. That's what we asked to prove there. Let's consider another proof. So to show this, we want to show that this one is equal to this. Our aim is to show from this place that it will be this. You observe that tan theta minus cot theta is down, while at the left hand side is up. Definitely you know that they have rationalized it. So in that case, we start by rationalizing it. Therefore, sec theta minus cosec theta over tan. Therefore, the left hand side will be equal to minus cot theta. We rationalize. The rationalization is we multiply both sides by the conjugate of denominator. That is tan theta plus cot theta over tan theta plus cot theta. So you see that we are coming there one by one. We have our tan theta plus cot theta there already. So we can now expand the denominator. So if I multiply this, I don't need to expand it. I'll just leave it like that, because what I need is already showing there, which is tan theta plus cot theta. But I can expand this. This is difference of two squares. If I expand it, tan theta times tan theta, we have tan square theta, minus cot theta times cot theta, we have cot square theta. From this place, I will now recall that this tan itself, tan is sec square theta minus 1. Also, this cot itself is cosec square theta minus 1. I've given you that before. Is cot square theta. In that case, the left hand side will be equal to sec theta minus cosec theta into tan theta plus cot theta over, instead of this tan theta, this is our tan theta here, sec square theta minus 1, minus cot theta is cosec square theta minus 1. From that place, the one will leave. It will remain sec square theta minus cosec square theta left. So the numerator will become, so minus 1, this minus times minus 1 will be plus 1, it will be 0. It will remain sec square theta minus cosec square theta left at the denominator. Then using difference of two squares, this will become sec minus cosec and sec plus cosec. From this way, sec minus cosec cancels each other. What we have left will now be tan theta plus cot theta over sec theta plus cosec theta. And that is what we have to show here. So that is proved. Let's consider another one. Another example, and the solution is another example. Study the example, your assignment, and the solution. Although the solution is there, you don't need to stress yourself, but just study it. It's your assignment. Here's another example.